All right. Good morning, everyone. How are we doing?
Good.
Wonderful. What we're going to do, guys, we are going to wrap up 2.1. Okay. And we should be able to start 2.2. And I know we are being recorded. Let me share the screen and share a few things with the whole class. So guys, I am working on your exam 3 study guide. Okay, it's kind of in the bottom. I changed it. Now I don't have all the sections listed. I basically copy pasted the previous stuff, and this is study guide. The exam will be on July 14th. Of course, we're not going to meet on Thursday. You will take the exam. The exam will be open for about 24 hours. You have to wrap it up before July 15th, 8 a.m. and you want to enter things properly. Here is the video, okay? And we have mentioned it many times. About the sections, I'll add, of course, I'm going to add 2.1, 2.2, and some of the sections we have done. And I'll compress it a little bit, okay? Just be aware of that, just a little bit, because when I teach, I want to start with the easy ones. And you need to know that. And even we're going to do some of those things today as well. We're going to start with something really easy. Then when we do the hard things, you will be just using those. So you kind of need to know it. At the same time, I may not give you the real easy stuff on the exam. So bear with me. Another good, I don't know if it's good or bad. In 2.2, we're going to talk about a lot of small ideas, tiny ideas, okay? And they're not that challenging really, but a lot of different things. So be a little patient. Going to MATLAB, all the problems from up to 2.2, I don't even have to show you. I'm pretty sure. Yeah, 2.2 is there. And we should be able to wrap up 2.2 by tomorrow. So Monday, Tuesday, Wednesday, we'll do a little bit of work. I'll leave a little bit of time if you have any questions, and you can always ask questions anytime. It's not a problem. If you miss a class, make sure you watch the video. It is synchronous. A lot of people aren't coming. Hopefully you guys are watching the video. You want to watch the video and you want to come to class and ask questions. Okay. Any questions, guys? Any questions at this point? I think I'm sharing my screen, guys. So we're going to go on and fiddle with some of the problems from 2.1. They are not that difficult, okay? However, you kind of need to know this to do 2.2. Yes, 2.2. So let's try number 34, okay? It's not difficult. I'm going to read the text. I know you probably can't see it so well. Number 24, the text. You always want to read the text. Not 24, 20, we'll do 20, 30, something like that, okay? So evaluate each function given the values of the independent variable. Independent variable is X. It's called the independent variable. So let's do something like number 30, okay? What do they mean? So they want us to find the value of the function where the independent variable is -1. And you have to do a little bit of calculation, all those things. All right, guys. So all we have to do, we talked about functions. We're going to talk about functions more today and tomorrow, actually, for the rest of the semester. All they're asking us to do is take this formula and replace x with -1 for the first time, then x with x plus 2, and you have to do some algebra, and x with x minus 1, negative x, I'm sorry. So let's go ahead and do it. So the first one isn't that bad. I'm going to say g of -1 is equal to, everywhere I see x, I'm going to go replace it with -1 and then do a little bit of math. And if I have a negative sign, I have to be extra cautious because signs do change. -1 squared is +1. -1 times -10 is +10. -3 is 11 minus 3 is 8. Okay, so that's that. We have done ones like this. That's not a big deal. I really wanted to do this because of this and this. I don't think we did this last time. And you're going to do this a lot more in 2.2. So I'm going to carefully replace x with x plus 2. Okay, I'm going to replace x with x plus 2 here as well. Okay, on the side, let me do it in red, then I'm going to erase it. What's x plus 2 squared? That's really x plus 2 times x plus 2. And we have done FOIL many times. Hopefully you can do it in your head now. X squared plus 4x plus 4. Just foiling. So this red stuff, I'm going to put it in black right here. Okay, you have a -10 here. You're going to distribute it over like so. Okay, and that's going to give you -10x, -20, -3, and let's put a line here. All you have to do is collect the like terms. X squared doesn't have a companion. He's all by himself. 4x and -10x gives me -6x. And 4 minus 3 is 1. -19 is what I'm getting. So that's your final answer, guys. I'm going to erase the red stuff. I'm going to pause here a little bit. Pause here a little bit before I do the next one. That's our part B. I'll give you a couple of minutes to process it. All right, guys, if you have any question, just feel free to unmute yourself and ask. Don't be shy. All right, the very last one, same story. I'm going to replace x with this time x will be replaced with -x everywhere throughout. If it's negative, you have to be cautious about the parentheses. Put the whole thing in parentheses. Doesn't hurt. It may make you do one extra step, but it's worth it. X squared, negative square is positive. -10 times -x is +10x. -3, that wasn't too bad. Done. Done. Any questions, guys? All right, moving on, doing a few of the last problems. You should be able to do them. They're very repetitive. It's the same thing. There is nothing going on here, but we'll try one. Let's see what they're saying. Graph the given square root function. Let's do one. Let's do, let's read the question very carefully, okay? Let's do the first one. Graph the given square root function. Square root function is a function with a radical sign. F and G, there are two functions really. Use the integer values x given to the right for each function to obtain ordered pairs, because only non-sure. I'll explain that to you. Okay, all right, guys. So let me do this one for you guys. And if you have a preference, I can do it on the graphing calculator. But if you don't care, I will do it on Desmos. It's easier to see and the graphs look prettier. Okay, so what they're really saying is they're asking you to find, let's do the table first, okay? And this is X. And I don't know how you write it. This is one way of writing it. X, f of X, and g of X. I'm going to just use the same table for both. All right, guys. I'm going to carefully do the first one. When I'm working on this one, okay? The red one. I'm going to tell you why I'm calling this red in a second. The red one, F. I'm going to use this, and let's make this black. I'm going to do 0, 1, 4, 9. All right, now I'm going to go red. And I'm going to actually make this red. Okay, so when x is 0, square root of 0 is 0. When x is 1, square root of 1 is 1. When x is 4, square root of 4 is 2. When x is 9, square root of 9 is 3. Now, we're not putting plus minus because they don't have a plus minus, okay? When they don't give you a plus minus, if they give you plus, they want you to just do plus. So we're good. All right, guys? So, okay, that's the first one. We did it. No big deal. Then I'm going to make this green. Okay. G of X will be in green. All I'm doing is I'm looking at this formula. So square root of, this is how I'm going to do it. Square root of 0 minus 1, which is going to be minus 1 because square root of 0 is 0. And the next one, square root of 1 minus 1 is going to be 0. Square root of 4, the third one is 4. Square root of 4 minus 1. Square root of 4 is 2. 2 minus 1 is 1. Square root of 9 minus 1 is 2. So I have all the data points, okay? That's all I need. Now you can use your graphing calculator. If you want me to show it in both, I will, but you have to verbally tell me. Just show me how to use the graphing calculator. I think most of you will end up using Desmos because it's more convenient. So I'm going to leave this here. I'm going to go to Desmos. I'm going to graph these two functions, okay? F of X, remember, F of X is square root of X, and G of X is square root of X minus 1. It's a square root of, it's called the square root function, okay? Especially this one. Okay, if you want to put the radical sign, it's somewhere here in the bottom left corner and right here. Okay, cool. And then I'm going to do g of X. Now, if you want to be really consistent with your text, that's okay. You can write like that. G of X, if I'm not mistaken, was square root of X minus 1, square root of X. And you have to jump out of that radical sign. Okay, now let me see what else I can do here. Let's do this setup. Let's make it a little bigger. Yeah, that's much better. So take a look, guys. Take a look and let's zoom in a little bit. So they're asking a lot of questions, actually. The points are going to work out fine. I'll tell you why. just look at the red one, the first one. 0, 0, we got 1. We got 1, 1. 1 is here, 1 is here. I'm just looking at the red one, okay? If you really want me to do that, I'll do it like so. I'm going to take this guy. I'm going to bring it back home. Take a look at this graph. Oh boy. Yeah, not bad. Take a look. I'm looking at the red one, okay? 0, 0, 1, 1. 4 is 2. And 9 is way out there. Trust me, it works out. And this blue one works out too. So I'm going to just go here. One question that our question asks us, once you have obtained your graphs, describe how the graph G is related to graph F. It's something we're going to study later. Okay. You won't kind of see it a lot right now. So I am going to say, let me look at one more thing. So this will make sense a little later. Right? Give me 1 second. I don't know why it's acting so funny. Okay, we'll get rid of this. Okay, so the relationship between the red graph and the blue graph, the red graph is f of x square root of x, g of x is square root of x minus 1, is it almost seems like they're pushing the blue graph down by 1 unit. They took the red graph and just pushed it down as follows. Let me show you a little differently. Yeah, that's good enough. So what they're saying, guys, the way we're going to spend a long time doing it, they're pushing it 1 unit down. That's what they want you to say. Okay. I'm not going to ask you this question on exam 3 because it really is from a chapter that's going to be done later, but they kind of want you to be aware of it. So basically they wanted you to graph, we graphed. They wanted you to draw the table. We did the table and we kind of explained how the two graphs are related. If this was, well, let me show you one more thing before we forget. If you just replace it with 2, don't go -1, go -2. Look what happens to the blue one. The blue one goes down 2 units. Replace this -2 with -3. The blue one goes further down 3 units. And this is exactly 3. 1, 2, 3. So kind of makes sense. Again, I'm not going to give you this on the exam because they're kind of preparing us for future. It's not really a part of this section, but I'm going to pause here a little bit, guys. Just pause here a little bit. I have the graph on the other page.
So just a quick question. So if we had that question on the exam, will we say push it down 1 unit?
Correct.
GX is pushing it down 1 unit.
Exactly. If you push down f of x 1 unit, you're going to get g of x. If I gave you, I won't give you because
And that's how we would say the relation is, right?
correct. Exactly. The relationship between the two graphs is the f of x is pushed down 1 unit to get g of x.
Okay.
Wonderful. Anything else, guys? Awesome. Okay, so I'm going to let you guys do it. Okay, this is very easy. Okay, I'm not going to do all of them. Remember, guys, we talked about the vertical line test. Vertical line test is a test for functions. Okay, I'm going to get rid of this. Here are some of the questions. So do they pass the vertical line test? The answer is here. I have 4 questions. This one passes the vertical line test. If you draw a vertical line, and if that all the vertical lines you can draw cuts your graph only at one point, the graph is a function. I'm going to write function. Okay, this one is not a function because here I can draw a vertical line that cuts the graph at 2 points, not a function. In math, we write not with the tilde, T-I-L-D-E is a symbol, tilde, wiggle. This is not a function because I can draw a vertical line that cuts the curve at 2 points. So I'm going to say tilde f means not a function. Now this one is a vertical line itself. So if you draw a vertical line on it, clearly it cuts that vertical line at numerous, infinitely many points. So it is also not a function. Okay, so in this page, only 57 is an example of a function. The rest are not because they fail the vertical line test. I'll give you a couple of minutes to process. I'll do a few more because these are easy to do, but you do want to understand. We're going to talk a lot about, is this a function? Is this not a function?
So which ones fail again?
They fail. This one fails. This one fails. F stands for function here. This one fails, and this one is good.
Okay.
Let's do a couple more. Okay, this is a good one. Okay, I'll have you guys do it then. How's that? Okay. Okay, so the vertical line test says if you can draw one vertical line, just one, okay? If you drop a drop of toxin in your drinking water, it's not going to be drinkable anymore. You're not going to drink it, okay? If you drop a little cyanide, you're not going to drink it. Same thing. If you can draw one line that cuts the curve at 2 points, it's not a function. So tell me, which one is a function, or which ones are functions, which ones are not? Anyone?
63 and 64 are not functions.
Okay. Okay. Let's. Okay.
Actually, wait.
Yeah. Revise it. Can you draw? Okay. What about 62? What about 62? Is it a function?
62 is not.
Correct. And let's write it. 62 is not because I can draw a vertical line that cuts the curve at 2 points. Okay, can you draw a vertical line for 61 that will cut the curve at multiple points? Line has to be vertical, up and down.
Yeah, it won't.
You cannot draw a vertical line, so it is a function, right?
Yes. And then those 63 and 64, because it does not touch 2 points, right?
Right. 63 has two parts, up to this much and then up to this much. 64 is the same. So what do you think? Is 63 a function or not?
Yes.
It is a function, correct. And what about 64? Is it a function or not?
Yes, it is.
Okay, correct, because I cannot draw a vertical line that will cut my curve. If the curve has a gap, I don't care about that part. I only care about the parts that exist. On the existing part, can I draw a vertical line that cuts the curve at multiple points? The answer for 61, 63, 64 is no. For 62, the answer is yes. The example is something you can probably see. I think that concludes our, I can do this. I'll do this actually, guys. There's nothing going on. It'll help us read teach us how to read a function, and these skills will come in handy later when we do something hard. Okay, use the graph to find each indicator. So when f is -2, I go for -2 on the x-axis right here. What's the value? The answer is -4. So I write -4 here. That's all they want. When f is 2, I go here. I'm going to go switch my color. I go here. I go down or up, depending on where my curve is, right here. I'm going to say -4 again. When f is 4, I'm going to go yellow. 4 is here. The value is here. And that's a +4. Okay. And let's go orange. -4 is here. To catch the curve, I go up, and that's a +4. That should be plenty. So that's how we read the value of a function from a graph. There's nothing to it, but here it is. Well, might as well do the other two. I'm going to go switch back to light orange, -3, a little tricky. Where would I go? It's right here, 0. All right, -1, right here, also 0. Because it curve passes through -1. I can give you a problem like this if I'm in good mood, but it'll be an easy one, right? There's not much going on. Reading the values from a graph. That ends chapter 2.1. Here is what I'm thinking, guys. I know this is not kicking me out. It's going to kick me out. Let's get out of this session real fast and come back really quickly. Okay, and when we come back, I'm going to start 2.1, but let me save this in case somebody says, I don't get that, we'll have it. Okay, this slide will be here for you. Okay, see you soon, guys. We're coming back with another session.